Okay, so when we are trying to solve a polynomial, um, the process, if you understand your factoring rules and your factoring ideas, this is actually very straightforward, very easy. Uh, the steps I have listed in the upper right corner, where your first step is to get everything on the polynomial to one side or to the other. Traditionally, we look at the left-hand side, and so that way our right-hand side is equal to 0. Your step 2 is that you're going to factor this down. This is the bulk of working any of these problems. After you factor this down as far as you can go, you can set each factor equal to 0 and then solve for each factor. You do want to pay attention to, do the instructions say give real solutions only, or does it say give all solutions, including imaginary and complex solutions? So in working this problem, before going to the graph, because the graph can do a lot, the more that you practice your factoring skills, the better you're going to be with what we're doing for solving polynomials, as well as when we get into rationals, which is the next section. So if I'm going to try and factor this polynomial, I want to go back to the rational root theorem, which says that I look at the constant, and I look at the factors of the constant, which are 1 and 13, and then I look at the factors of the leading coefficient, which is 1, and I take a look at all possibilities. So 1 divided by 1, I have plus or minus 1, and then 13 divided by 1, I have plus or minus 13. I look at all of those possibilities to help me determine what the factors are. So I'm going to start with 1, positive 1, and I'm going to synthetically divide using the positive 1. So when I write out my coefficients, this is 1, 15, 27, and 13. So we synthetically divide. I'm looking for a remainder of 0, which will be under the 13. So I bring down the 1, multiply that by 1, I get 1. Add 15, I have 16 times 1 is 16. And plus 27 is, what is that going to be? That's going to be 6 plus 27 is 33, so a 43. And then plus 1, times 1 is 43, plus 13 is 56, which is not 0. So a positive 1 is not one of our roots. So I'm going to try again, except this time I'm going to use a negative 1. Bring the 1 down. 1 times negative 1 is a negative 1, plus 15 is 14, times negative 1 is a negative 14. And let's see here, negative 14 plus 27, that is going to be 13, times negative 1 is a negative 13, and plus 13 is 0. So that is one of our roots, is x equals negative 1. Now, depending on how we work the problem, you may or may not have to go to the factor in this step, but sometimes we're going to need to factor, and that becomes a lot more important in the next unit. So it is still a good idea to take these to the factors, get that practice in. I'm going to take a look at this again. My remaining polynomial at this point is 1x squared plus 14x plus 13. And then you can use your quadratic factorization at this point. You need two numbers that multiply together to give you 13. When added or combined together, give you a 14. And so that is 1 and 13. 1 and 13. There's your factors. That has put us into step 2 in this process. Or if you, let's work with this one. I set each of these terms equal to 0. Now I've already covered one of them. So then I set x plus 1 equals to 0. I solve for x. So I get x is a negative 1, so that's another root. And then x plus 13 is equal to 0. And subtract 13 from both sides, I get that x is 13 is another root. So my final answer is -1, -1, and positive 13. I could have continued on with the synthetic division. My leading coefficient is 1, my constant is 13, so I run back into this same possible outcomes if for factors, but I know that +1 is not a factor, because if it's not a factor of the original, it's not going to be a factor of any of the subsequent factors. So I try -1 again. So -1, bring down your 1. 1 times -1 is a -1. 14 minus 1 is 13 times a -1 is a -13, and plus 13 is 0, leaving me with my other factor of x plus 13, and knowing that -1 is also a root. So either way, we'll get into the same answers. One of the difficulties with this, and why I also advise that you still work with factoring it down, work with the 4 steps I have listed in the upper right-hand corner, is if you immediately graph the original problem, if you just move straight into graphing that problem to get to your roots, you'll only see one intercept. And you'll see a tangent reflection at -1. And then you're not going to see the 13 because the standard window is 10 by 10. So your other intercept is beyond the range of what you're looking for. So unless you have that intuition or you worked with these a lot, then you're not going to see that third root and potentially get the problem wrong. So it's always good to just to keep multiple approaches in mind. Now we have a larger one. We have a much larger one. I'm going to go with the rational root theory again to help start. The problem is already set up with all the information on the left-hand side. So this is the factors of the constant. It's plus or minus. It's a -3, but since we're doing the plus or minus, it really doesn't matter. So I have the possibilities of 1 and 3, and then in the possible factors of the leading coefficient, I have 1 and 7. I know that 7 is going to have to make an appearance at some point because it's the leading coefficient. It has to. But we're going to try and work with some of the smaller numbers first. This leads into the possibility of if I divide things by 1, I have plus or minus 1, plus or minus 3. When I use the 7, I have plus or minus 1/7, and I have plus or minus 3/7. So let's just start and see what we get. So let's start with a +1. +1, I have a 7, -22, -4, +22, and a -3. Hopefully this will give me 0. So I bring down the 7. 7 times 1 is 7 minus 22 is a -15 times 1 is a -15. -15 minus 4 is a -19. -19 times 1 is -19. And then 22 minus 19 is a +3 times 1 is 3 minus 3 is 0. So x equals 1 is one of my roots. I run into that same outcome of I have a 7 and I have a 3, which as my 3 is my constant, 7 is my leading coefficient. So I'm still working with these, what are they, 8 possible, I have these 8 possible roots. Since 1 worked the first time, let's see what happens if I do this again. So here we go. Bring down my 7. Times 1 is 7. Minus 15 is is a negative 8, and times 1 is negative 8 plus negative 19 is negative 27, and times 1, negative 27, that's not going to line up because that is not going to be 0. That's going to be a negative 24. Not going to work. So let's try this again. But this time, let's do -1. I'm trying to rule out the easier possibilities first in this case, and it all has to do with this. It all has to do with this 7. So bring down to 7 times -1 is a -7. This is not looking good at the moment. -7 minus 15 is negative 22. Negative 22 times a -1 is a positive 22. Okay, so this does look okay, because 22 minus 19 is 3 times -1 is -3 plus 3 is 0. So there's another one of my roots, which is -1. And now I have, as leftover, I have 7x squared minus 22x plus 3. And so I am going to stop the synthetic division and go back into just basic factoring of a quadratic. You could use quadratic formula to get to the roots at this point. But what I'm looking for now is some combination, because I know 7 times 7, or sorry, 7x times x is going to give me 7x squared. Now I'm looking for 7 times a number plus, or in combination with, some number times x that gives me a negative 22, that those two numbers, when multiplied together, give me a positive 3. So since the 3 is positive, that means that I have to multiply either positive and positive or a negative and a negative. Since my middle term, my linear term, is a negative 22, I can't get negatives from positives, so I know both of those numbers have to be negative. And I see that 7 times 3 is 21, and when combined with a -1, that's going to give me the quadratic, this trinomial. I now set each of these terms equal to 0, so 7x minus 1 equals 0. This is 7x is equal to 1, which is 7x is equal to 1/7, and x minus 3 equals 0. So x equals 3. So we had -1. Our final answer is x equals a -1, 1/7. I put my roots, I put my solutions, my zeros, and my x-intercepts. They all mean the same thing. I'm putting them in ascending order. I'm putting them in ascending order. This is the preferred. Is it incorrect if you put them in a different order? No, but with 4 answers, that is 24 different possible orderings of these numbers that I have to take into consideration. So when it comes to grading, it's a whole lot easier if you put them in ascending order. So, and if you want to learn how to do that kind of math, I can show you at another time. But that's solving. That is solving. Every problem is going to revolve around those in some way, whether they're all real solutions, whether they are real and rational, real and irrational, or complex or imaginary. The process is still the same. And so you can work with all of those different problems. Next, we're going to be talking about rational functions, what makes up irrational functions. And this is another unit that we're going to be getting into.